Okay, so this is the review for your Chapter 6 final. I just want to point out before I start that on page 348 through I think it's 351, it really has all of Chapter 6 that you can review on your own. So if you just want to study and this video is not enough, you can do that. Also, your journals have really good notes. There might even be 1 or 2 questions from the final that I snuck into the journal. So review your journals. If you know how to do that stuff, you'll do fine. So these are 8 questions that I found that are representative of, I would say, about 80 to 90% of that whole test. So if you can do these 8 problems, you're good. I'm going to work them out with you right now, though. So remember, when something's on the outside of the radical, this symbol right here, that it's the root. So this is saying take the 4th root of 16. So in other words, what number can you multiply by itself 4 times to get 16? So if you have a calculator, you could just push, scientific calculator, this X of root button, and it will just, you could just push the 4 afterwards, and then inside the Radican, you can push the 16, and it's done for you. But a lot of us don't have the scientific calculators that can do that, so you almost have to guess. I'll start with a 3. 3 times 3 times 3 times 3. Well, 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. 81 is too high, therefore 3 is too high. If 3 is too high, I should go lower. So I know 3 is not going to work. And I know it's lower than 3, so I will try 2. 2 times 2 times 2 times 2. Again, I'm doing it 4 times because it's to the 4th root. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Oh, it matches. So the 16 to the 4th root would equal 2. So the answer is 2, but there's a negative outside looming there. So the answer is actually negative 2 to that first question. Okay, looking at the second one, this would be really easy if you could push the button there, right? But if you can't, you just have to guess and try different numbers. I don't actually know. I think it's a 3. So I'm going to try 3. Oh, let's rewrite this, though. The whole point of this question, and you have one similar to it on your test, is to see if you know how to rewrite it so it's a little more manageable. So what goes inside the Radican is the 729. Which one of these go into the root? The 6. And which one goes to the power? The 1. So I think it's a 3. I think 3 times 3 times 3 times 3 times 3 times 3, should be 6 times, equals 729. 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243, times 3 is 243, times 3 would be 729. So again, the answer to this would be 3, but then you have to take it to the power. Once you do the 6th root, you have to take that answer to the power, but 3 to the 1 power is still going to be 3. Good. Okay. Question number 3. If you have a 7 to the negative 2 power times a 7 to the 4th power, what I want you to observe is you have the same base number and that you're multiplying. If it meets those 2 conditions of having the same base, in this case it's a variable, right? And you're multiplying, it's really simple. You can just add the exponents. So let's do that real quick. A negative 2 and a 4. Well, negative 2 plus 4 would just be a 2. So the answer to this would be z squared, or z to the 2nd power. And there's no other work to be done because it's a variable. Oh, getting emails. Oh, looks like we made the news. Good job, Eagles. Okay. Number 4. B to the negative, or B to the negative 5th. I think this is just a scribbling mark. B to the negative 5th. A0, B to the negative 8th power. So it's really just what I would call a should it stay or should it go type problem. And most of my students do very well at these. You just got to remember that's what it is. So if it's b to the negative 5th, that would go because it's a negative exponent. And so that b to the 5th would go down. And let's go to the denominator now. Anything to the 0 power automatically equals 1. Now, since the identity property states that 1 times anything is just itself, you don't even need to write the 1. This is why teachers check their emails so much, guys. It's all these emails we get. So that's gone. Now b to the negative 8. Again, it's a negative, so it should go. So it should be, whoops, it should be b. I don't know why I'm writing an s. To the 8th power. Now, everything's been done correct. It looks like we got the answer, except when you have the same base number and you're dividing, you subtract. Remember, when we had the same base number on this question and we were multiplying, we added. Now we have the same base number and we're dividing. And since the inverse of multiplication is division, the inverse of adding is to subtract. So 8 take away 5 would be 3. So the answer would be b to the 3rd power. If I'm going too fast, please refer to these pages for the review, or your journals. Okay, you'll get also a question like this one. 2c to the 4th power over 5 to the negative 3rd power. Now the whole thing in parentheses is to the negative 3rd power. And if it's negative exponent, does it stay or does it go? Right, it's going to go. So 2 to the negative 3rd power would be 2 times 2 times 2, which is 8. C, but it would go to the bottom because it's negative. C to the 4th power, when you have a power to a power, you multiply. 4 times 3 is 12, but since it's a negative exponent, it goes to the denominator. It goes down. So it's 8, C12. And this 5, since it's being influenced by the negative exponent, is moving up. It goes, right? So 5 times 5 times 5, 3 times, would be 125. And that's your answer. You can't simplify it anymore, so there you go. Okay, number 6. Another email. This one you have to think a little bit. 2 to what power equals 1 over 128? So what I like to do in these problems is think about 2 times what would be 128. So let's do 2 to the 1st, 2 to the 2nd, 2 to the 3rd power would be 8, 2 to the 4th power to be 16, to the 5th power to be 32, to the 6th power to be 64, to the 7th power 128. Okay, we found it. You just double the numbers each time, and that's how you do 2 powers. So it's to the 7th power. But if I do 2 to the 7th power, I'm just going to get 128, and I need a 1 over 128. So how do I get that 128 to go to the denominator? Simple. Remember, if you have a negative exponent, it goes. So 2 to the negative 7 would equal 1 over 128. So that means that this x actually is a negative 7. So the answer to this is x equals negative 7. All right. Got a few more. Okay. 256 to the x plus 2 power equals 16 to the 3x minus 1 power. What to do? Remember, you have to have the same base number in order to make the exponents equal to each other. And these are not the same. But maybe we can turn them to the same. In fact, going back to this previous problem, if I were just to do 2 one more time to the 8th power, it would be 256. Right? So, really, 2 to the 8th power is the same thing as 256. I'll just bring this down to x plus 2 up here. And 16 is really just 2 to the 4th power. So I'm going to write 2 to the 4th power up here and just bring the rest down. Okay, now we have the same base number. If you have the same base number and they're equal to each other, that means the exponents also have to be equal. That means 8 times the quantity of x plus 2 equals 4 times the quantity of 3x minus 1. Now we just distribute. There's a shortcut. I'm looking at my time on this video, so just remember you could have divided. And you just solve for x, right? Take away 8 from both sides. Having to hurry. It's going to cut out. We have 16 equals 4x minus 4.